Welcome to helpyourmath.com. In today's video, we're going to be solving for x. In these problems, they're mostly going to be very many variables and very few numbers. And so the goal of this is always going to be get your x on the side that makes it positive and move everything else to the other side by using opposite operations, like the additive inverse or the multiplicative inverse, or anything you need to do to make your x variable positive. It makes it really difficult when you're dealing with terms that have sums and additions and you're dividing by a negative term and don't know how to use the rewrite rule, which states whenever you're dividing a difference of two numbers by a negative number, the difference switches over. So if you have a minus b divided by negative 1, when you divide by negative 1, you get b minus a. And that's something that's really important, all right? But instead of using the rewrite rule, which is a little bit ahead of elementary algebra, what we'll do is we'll concern ourselves with always keeping the x on the side that makes it positive, all right? And so let's begin with the problem set. We have here number 1. And here we have z is equivalent to 5x's, take away y. Now keep in mind that when you're subtracting these variables from each other and they're not the same, you can't do an addition or subtraction unless they're identical. So here, while I use the additive inverse to move the y away from the x so I could isolate it, these two may cancel out, but these two don't do anything. They don't add up. There's no difference you can do here. All right, so we're just going to leave it as z plus y is equivalent to 5x's. And the final step here is to divide both sides by 5. So I'm going to divide both sides by 5, and I get x is equivalent to the z plus the y over the 5. Moving on to problem number 2. We see we have p is equivalent to 4y's plus 4x's. What we want to do again is solve for x. So what we're doing is we're isolating the x term first, and then we're going to isolate the x variable. So let's get rid of this 4y by subtracting it to both sides. Using the additive inverse, the opposite sign first, these cancel. We have p take away 4y's are equivalent to 4x's. The next step is then just to divide both sides by 4. We're dividing everything at once by 4. Here these 4's go away and we can see our solution here for x. X is equivalent to p take away 4y's over 4. Oh, whoa. This should be boxed in entirely. Moving on to number 3. In number 3, we have 2y's are equivalent to 2x's plus k. And in this, again, we want to keep the x on its own side again, and we have the k joining the x term, so we're just going to subtract that k to both sides. These k's will cancel, and we have 2y's. Take away a k are equivalent to 2x's. And again, we're just going to divide both sides by 2, so we can solve for our x value. These 2's go away, and we're just left with x is equivalent to 2y's minus k over 2. And we just want to box that in. Moving on to number 4 now. Now in this case we have a fraction. It's not just so simple where we have these multiplying things and these adding and subtracting things. We have a quotient here. It's y take away x over 2. And again, we want to isolate this x term and get it on one side. Before we can do anything with the x, we have to get rid of this division. And so this is one single term up here as a binomial term. And to get rid of the 2, what we're going to do is we're going to multiply both sides by positive 2. And what this does is it gets rid of the division. This is the opposite operation to the division, right? Multiplication and division, they sort of cancel each other out. They balance each other out to 0. And so here we have 2p. 2p's are equivalent to y take away x. Now the main issue we have here is that our x value is negative, and what we really want is a positive x term. So let's move the x from the right hand side to the left hand side. So we're adding x to both sides. These cancel and we have x plus 2p's are equivalent to y. And now to solve for x, all we have to do is get rid of that 2p. So it's a lengthy process, but if you can be patient, you can get this perfectly right. All right? So we subtract 2p to both sides. What we're going to get here is the 2p's cancel and we have x equals y take away 2p's. Here's our next solution. Final problem here, number 5. We have the same issue. We have a negative 2x, right? So we have 2y's are equivalent to p take away 2x's. So our first step in this is going to be to take that 2x and move it over first. All right, so we can get it to be a positive. So we're adding 2x's to both sides. These will cancel. These can't add up. So we have 2y's plus 2x's are equivalent to p. Our next step is to get rid of the 2y's. So we're moving the 2y's to the other side. These 2y's cancel. We have 2x's left over are equivalent to p take away 2y's. Our next step is then to get rid of this 2 next to the x, so we can isolate the x variable. And we just divide both sides by 2. And these go away. We have x is equivalent to p take away 2y's over 2. And that's our solution. Thank you.